Assalamu alaikum. We know when an object moves in a circular path, then it is said to be in circular motion. In this video, we are going to discuss a few parameters related with circular motion. Let's do it. First, I'll start with angular displacement. I'll tell you what is angular displacement. Angular displacement is represented by letter theta. What is this angular displacement? To make you understand about angular displacement, I will draw a circular path in which an object moves. This is a circle or a circular path with a center O. Suppose an object is present initially at a point A. Now, I connect this object to the center. I can call this line as radius of this circular path. Okay. Suppose the object starts moving in this direction, in the clockwise direction. After some time, after time t, if the object moves to a new position, let's say position B. Okay. When time is 0, when t is taken as 0, the object is found to be at point A. After some time t, it reaches a new position B. So along with the object, this line which connects the object to the center of the circle also moves. Am I right? See? Right. So the angle swept by this line when the object moves along the circumference of the circle is referred as angular displacement. So here this angle swept by this line is referred as angular displacement. Right? Now suppose if the object covers this arc length while moving along the circumference of the circle is taken as S, then this arc length, angular displacement and the radius of this circle can be related with each other. Now before doing so, let me write the expression for angular displacement. Here angular displacement is nothing but the angle between, what is the angle between A, O and B. A, O and B. So here in the diagram it is represented by letter theta. So here theta represents the angular displacement. Got it? So simple. And how do we measure angular displacement? Angular displacement is measured with the help of an unit called as radian. It is measured using the unit radian, which is in a simple form written as rad, radian. Clear? We'll go ahead. Now I'm going to relate, as I told you earlier, I'm going to relate this arc length with the angular displacement, and radius of the circular path. These three are related. Relation between yes, R and theta. What are they? You see here, angular displacement theta is found to be equal to length of the arc, divided by the radius of the arc, radius of the arc. No, already in my previous video I have explained this. What is the length of the arc? Here it is kept as such, which represents the angular displacement. What is this? Angular displacement. Length of the arc is represented from the diagram as S. It is divided by radius of the arc is nothing but R. Okay, this is the relation between length of the arc, radius of the arc, and angular displacement. Clear? From this, the displacement, that is length of the arc, is found to be the product of radius of the circular path and angular displacement. I box this for better visibility. Clear? So that's all about the angular displacement. So what is angular displacement? It is nothing but the angle swept by the line which connects the center of the circle to the object moving along the circumference of the circle. Clear? So whatever angle it traces or it subtends or it sweeps is referred as angular displacement. Clear? Now, three different words are used here. Now, if you call it as sweep, the angle swept by the object. The second, angle trace or subtend. The word subtend is used. Angle subtended by the object when it moves along the circumference of the circle. Clear? The next very important parameter related with the circular motion is nothing but angular velocity. Is the next angular velocity. Angular velocity is represented by letter omega. Angular velocity is represented by letter omega, and it is nothing but rate of change of angular displacement. What is omega? Omega is actually rate of change of angular displacement. Now, in some cases, the change in angular displacement is a represented letter delta theta. No? For a time delta t. For time delta t. It is nothing but omega, angular velocity. Here, in limit delta t when tends to 0, then we get this expression actually. And the limit of delta t tends to 0, then this expression delta theta upon delta t can be represented as d theta upon dt. Now here, instead of doing all these things, I have written the final expression. So what does it mean? Here d theta means change in angular displacement with the change in time. For this change in the time, the angular displacement changes to this extent. This is what mentioned here. Now how do we read this? It is read as the rate of change of angular displacement, and it gives us angular velocity. And what is the unit? How we represent, how do we measure angular velocity? Angular velocity is measured using unit radian per second. Radian per second. Okay. How do we get this unit? Let me explain this to you. Here, angular displacement is measured in a radian. This is mentioned here. And the time is measured in second. Now, as the time is present in denominator, when it is taken to numerator, we get s power minus 1. Clear? This is how we get the unit of angular velocity. Now here, the angular velocity is actually a vector unit. It is a vector unit. It has got a direction. Clear? Along with the magnitude. It is a vector quantity. Vector quantity. Whereas angular displacement is a scalar quantity. It is just a number. It doesn't have any direction. Remember that. So, it has got only magnitude, no direction. So it is a scalar quantity. It is a scalar quantity. Let me provide some more information about the angular velocity. When I say it is a vector quantity, in what direction it acts? Let me show you. Now suppose I have an object moving in a circular path. This is the circular path. See, how do I show this? Actually, it is a circular path, but appears like an ellipse. No? Actually, this is a circle. If I show it in this manner, then it appears like this. Fine. So this is a circular path along which an object is moving. Then the angular velocity will act in this direction, no? Along this line with arrowhead. Roughly speaking, angular velocity always acts along the axis of rotation. What is this? It is axis of rotation. This is axis of rotation. Along this, the angular velocity act. Clear? You remember this? And it is in accordance with the right hand rule. Clear? Now suppose I place my hand in this manner, and I curl these 4 fingers. The direction in which these 4 fingers move give the direction of motion of the object in the circle, the circular path. Here, the object is moving in this direction. If it happens so, then the direction in which the thumb representing, the direction the thumb represents, provides us the direction of angular velocity. Clear? This is how we can easily get the direction of angular velocity when an object moves in a circular path. Suppose if it reverses its direction, if it moves in clockwise direction, then the angular velocity will act in the downward direction. See, in this manner. Got it? When the object moves in clockwise direction, the angular velocity will act downward. That's all about the angular velocity. Now I'll go ahead. I'll tell you what is the angular acceleration. Third parameter that you need to know related to circular motion is nothing but angular acceleration. Angular acceleration is represented by letter alpha. Letter alpha. And what is this? Let me show you. Here, angular acceleration, which is represented by letter alpha, is actually a rate of change of angular displacement, d omega divided by dt. Change in angular velocity with time. Rate of change of angular velocity is referred as angular acceleration. Let me write this one here. It is rate of change of angular velocity. Rate of change of angular velocity. Now, what is the meaning of rate of change? Whenever you divide a quantity with time, then we use the term rate. Got it? No, this I have told you people earlier in my previous video. Now, what is this angular velocity? Let me write its definition here. Rate of change of angular displacement is known as angular velocity. Clear? And how do we measure angular acceleration? Angular acceleration is measured in unit radian per square second. Radian per square second. How do you get this? It is obtained very easily. I suppose here d omega divided by dt. Now omega. Now I just split this d upon dt omega here. In the place of omega, I write this equation. What I get if I do so? See, dt d upon dt here d theta upon dt is what I get. Now, if it is so, then the final equation that I'll get is d square theta upon dt square. Fine. Here, this represents second order differentiation of angular velocity, angular displacement. I'm sorry. Second order differentiation of angular displacement. Clear? So here, angular displacement is measured in radian and the time is measured in second. So here square of second. So s power 2 when it is present in denominator, when it is taken to numerator, s power minus 2. This is how one get the unit of angular acceleration. I hope you have understood. And one more thing I do want to tell you about the angular acceleration is, it is not necessary for angular acceleration to act along angular velocity, though it has got direction, but in order to act along angular velocity. Okay, yeah, it is a vector quantity. It is not acting. It is not necessary for angular acceleration to act along angular velocity. Okay, that's all about these parameters. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.